Hello guys, in this video we are doing a question for chemical equilibrium, which is for the reaction of P and Q to form PQ. So the question reads, consider the balanced equation below for a hypothetical reaction that takes place in a sealed 2 cubic decimeter container at 300 Kelvin. Also we have our reactants P and Q2, and to form PQ as our products. Define the term chemical equilibrium. So chemical equilibrium is defined as a stage in a chemical reaction when the rate of forward reaction equals the rate of reverse reaction. The amount of each substance present in the equilibrium mixture at 300 Kelvin is shown in the table below. So the table we have reactants and products this side, then the amount at equilibrium. The amount of equilibrium meant is the number of moles. The temperature of the container is now increased to 350 Kelvin. When a new equilibrium is established, it is found that 1,2 mole of P is present in the container. Is the heat of reaction positive or negative? So in this case, increase in temperature increase the number of moles from 0,8 to 1,2. Yet we know that P is the reactant, so meaning the reverse reaction is being favored in this case. So our heat of reaction should be negative. Use Le Chatelier's principle to explain the answer in question 6.2.1. So what we need to state here is the Le Chatelier's principle explained in terms of temperature. Increase in temperature favors an endothermic reaction, then reverse reaction is favored. Therefore, the reaction is exothermic. Since we realize that the reverse reaction is favored, which is the endothermic, so therefore the forward reaction is exothermic, which is the opposite. 6.2.3. Calculate the equilibrium constant at 350 Kelvin. So what we can do to solve this question, we must have the equilibrium concentrations. So we are going to draw a table that will assist us to find the equilibrium values, which is the concentration that we are more interested in. So at this point, write our reaction species. So we have reactants. We start with reactants 2P, then we have Q2 followed by PQ. So the first thing we have here is the initial number of moles, followed by the change in moles, then equilibrium number of moles. Lastly, we have equilibrium concentration. So we are going to take the point when the reaction was at 300 Kelvin. Then we use these ones as our initial number of moles. So in this case, the initial number of moles of P is 0,8. then 0,8 and 3,2. So what is going to happen here is, like, since the reaction favored is the formation of reactants, the number of moles of reactants are going to increase and the number of moles of products will decrease. The question says at 350 degrees the equilibrium number of moles of P increased to 1,2. So we have 1,2 here. So to find the change, there was an additional of, say, 1,2 minus this one, 0,8, we get 0,4. So we added 0,8 to this one. Then from there, we want to balance this one. We follow the mole ratio to find the change in number of moles of these other species. So we can see P is in the ratio 2:1 with Q. So number of moles of Q2 is half of number of moles of P. So we come here and say half of 0,4 is 0,2. Then this side, P and PQ, they're in the ratio 2:2, which is similar to 1:1. So this will stay 0,4. But since we said the reactants are increasing, in the number of moles of reactants is increasing, therefore we are going to say 0,8 plus 0,2, then we get 1. But for this side, which is the product side, since we are favoring the formation of reactants, so the number of moles of products is going to decrease. So in this case, we're not going to add, we have to subtract, since we know that the number of moles of products are decreasing. So it's 3,2 minus 0,4, which is equivalent to 2,8. Then now we want to calculate the equilibrium concentration. Concentration, we use the formula number of moles over volume, where our number of moles, we use the number of moles at equilibrium. So this will be 1,2 over, in the question we are told that the reaction is taking place in a sealed 2 cubic decimeter container. So we divide by 2, then we'll get 1,2 divided by 2, this gives us 0,6. So we have 0,6 concentration here. Then for this one, this will be 1 divided by 2, then it gives us 0,5. Then for this one is 2,8 divided by 2, then we get 1,4 mole per cubic decimeter. So now I want to calculate our Kc, which is the equilibrium constant. Equilibrium constant, we said it is the ratio of products and reactants. So in this case, our product is PQ and our reactants is these two, P and Q2. So this is concentration of PQ on top. Then we take the mole ratio, which is a 2. Then we square here, it changes to be an exponent. Then our reactants, it's P and Q. P is a 2, the mole ratio is a 2, so we square this side. So now we just substitute with the values of the concentrations. Concentration of PQ is 1,4 squared over concentration of P, it's 0,6 squared. Then concentration of Q2, it's 0,5. Then this will give us our final answer, 10,89. And 6.2.4, how will the equilibrium constant calculated in question 6.2.3 be affected when the volume of container is decreased at constant temperature? Choose from increases, decreases, remains the same. Give reason for your answer. So decreasing the volume of a container, it means you are increasing the pressure. Yet we know that increase in pressure have no effect on the Kc value. The only thing that have effect on the Kc value is the temperature. That will change the concentration of either products or reactants. So our answer is it remains the same. Then the reason for the answer is only temperature can change Kc, not pressure. So in this case, temperature is constant, so there will be no change in our Kc.